Good morning, student. Let us start with today's lesson on the chapter structure of atom. So in the previous class, we had discussed about explanation of black body radiation and photoelectric effect using Planck's quantum theory and dual nature of electromagnetic radiation. So let us begin with today's lesson. So today we are going to discuss about emission and absorption spectra and emission spectrum of hydrogen and Reidberg formula along with Reidberg constant. So let us begin. So students, we have studied about the electromagnetic spectrum consists of radiations of different wavelengths and frequencies. So an instrument which is used to separate the radiations of different wavelengths or frequency is called spectroscope or a spectrograph. And a spectroscope consists of a prism or a diffraction grating for the dispersion of radiations and a telescope to examine the emergent radiations with the human eye. However, if in a spectroscope the telescope is replaced by a photographic film, the instrument is called a spectrograph, and the photograph or the pattern of the emergent radiation recorded on the film, that is the photographic film, is called a spectrogram or simply a spectrum of the given radiation. So we can say that the branch of science dealing with the study of spectra is called spectroscopy. So the spectra are broadly classified into emission spectra and absorption spectra. So let us discuss each one of them in details. So first one is emission spectra. So what is emission spectra? When the radiation emitted from a source, for example from the sun, or by passing electric discharge through a gas at low pressure, or by heating substance to high temperature, etc., means radiations are emitted from the source by doing these things, etc., is passed directly through the prism and then received on the photographic plate. The spectrum obtained is called emission spectrum, and depending upon the source of radiation, the emission spectra are mainly of two types. First one is continuous spectra. So first let us discuss what is continuous spectra. As you can see over here, when the white light from any source such as sun, bulb or any hot glowing body is analyzed by passing through a prism, it is observed that it splits up into 7 different white bands of colors from violet to red with rainbow, as you can see over here in the diagram. So these colors are so continuous that each one of them merges into the next. Hence, the spectrum is called continuous spectrum. It may be noted that over here that on passing through the prism, the red color with the longest wavelength is deviated least, while the violet color with shortest wavelength is deviated the most. So this is known as continuous spectra. Switching towards the second type, that is line spectra. As you can see over here, when some volatile salt, for example suppose sodium chloride, is placed in the Bunsen flame or burner, or an electric discharge is passed through a gas at low pressure, light is emitted. So the color of light emitted depends upon the nature of substance. For example, sodium or its salts emitting yellow light, while potassium or its salts give out violet light. These are the colors you can show when you are going to do the inorganic detection, salt detection in flame test. And if this light is resolved in a spectroscope, it is found that no continuous spectrum is obtained, but some isolated color lines are obtained on the photographic plate, separated from each other by dark spaces. So this spectrum is called line emission spectrum, or simply we can say line spectra. Each line in the spectrum corresponds to a particular wavelength. You can see over here as well, we are getting for sodium salt, we are getting two yellow lines having certain wavelengths. So further we can say that each element gives its own characteristic spectrum, differing from those of all other elements. So for example, just we have seen that sodium is always giving two yellow lines corresponding to wavelength having 5890 angstrom and 5896 angstrom. So hence the spectra of the elements are described as their fingerprints, different from each other, like the fingerprints of the human beings. So further we can say that the line spectra are obtained as a result of absorption and subsequent emission of radiation or energy by the electrons in the individual atoms of the element. Hence the line spectrum is also called atomic spectrum. So I hope it is clear to you all. Let us proceed towards the second type, that is absorption spectra. So as you can see over here, when white light from any source is first passed through the solution or vapors of a chemical substance and then analyzed by the spectroscope, it is observed that some dark lines are obtained, and these dark lines are supposed to result from the fact that when white light containing radiations of many wavelengths is passed through the chemical substance, radiations of certain wavelengths are absorbed, depending upon the nature of the element. Further, it is observed that the dark lines are at the same place where colored lines are obtained in the emission spectra for the same substance. This shows that the wavelengths absorbed were same as were emitted in the emission spectra. So we can say that the spectrum thus obtained is therefore called absorption spectrum. You can see over here the absorption spectra, white from a white light source we are having, and after that we are having the absorption spectra on the photographic plate. So I hope it's clear. So let us proceed, that is emission spectrum of hydrogen. So we are knowing that when hydrogen gas at low pressure is taken in the discharge tube and the light emitted on passing electric discharge is examined with a spectroscope. So the spectrum obtained is called emission spectrum of hydrogen. It is found to consist of a large number of lines which are grouped into different series. You can see over here the series of emission spectrum of hydrogen, and these series are named after their discoverers. So the names of these series and the region in which they are found, you can see over here. So first one is name is Lyman series, second is Balmer series, third one is Bastian series, fourth one is Brackett series, and fifth one is Fund series. So these are the names of the series, and you can see over here the region in which these series lies. Like for Lyman series, it is lying in ultraviolet region. Like for Balmer series, it is lying in visible region, and for Bastian series, it is near about infrared region, and for Brackett and Fund, those are very far from infrared region. So this is the line spectrum of hydrogen, which is obtained when hydrogen gas at low pressure is taken in the discharge tube and the light emitted on passing electric discharge is examined with a spectroscope. And we are knowing that hydrogen being the lightest element, the number of lines produced in the spectrum is minimum. So as the gases with high molecular masses are taken, the spectra become more and more complex. That's why initially line spectrum of hydrogen was being studied. So, and these lines are lying in various regions as well as having different series name. So I hope you have understood the emission spectrum of hydrogen. So let us proceed towards another formula, that is Reidberg formula. Although we are knowing that a large number of lines are present in the hydrogen spectrum, the previous one which we have just seen, the line spectrum of hydrogen, those are the electronic transitions previously. So we can say that a large number of lines are present in the hydrogen spectrum. Reidberg in 1890 gave a very simple theoretical equation for the calculation of wavelengths of these lines. So the equation gives the calculation of wave numbers of the lines by the formula. We can denote it as nu bar, that is the wave number will be equals to capital R bracket 1 by n1 square minus 1 by n2 square, where R is called Reidberg constant and it is having a value of 109677 per centimeter, or we can write it as 1.097 into 10 to the power 7 per meter. N1 and N2 are the whole numbers, and for a particular series N1 is constant and N2 varies. For example, if we are talking about Lyman series, then N1 will be equals to 1 and N2 will start from 2, 3, 4 like that. And for Balmer, N1 will be 2 and N2 will be 3, 4, 5 like that. And for Paschen series, N1 will be 3, N2 will be 4, 5, 6 like that, and so on for the rest of the series. So we can say that the expression 1 is called Reidberg formula. And for hydrogen like particles, we can write the formula as nu bar will be equals to R multiplied with 1 by n1 square minus 1 by n2 square multiplied with z square. We are knowing that here z is the atomic number of hydrogen like particle. Hydrogen like particle means having one electron. So when n1 is equals to 2, the above expression the expression given above is called Balmer's formula, as it was first put forward by the Balmer in 1885 to explain the series of lines bearing his name, that is the lines in the visible region. We are knowing that Balmer series lying in visible region, and there is one limiting line, we can say limitation, that of any spectral lines in the hydrogen spectrum is the line when N2 in the Reidberg formula is infinity. When we are taking N2 as infinity, then that will be the limiting line of any spectral series in hydrogen spectrum. So this is Reidberg formula. So let us discuss some question over that to get you more clear. So the first question over here is like this: what is the wavelength of light emitted when the electron in a hydrogen atom undergoes transition from an energy level with n is equals to 4 to an energy level with n is equals to 2? What is the color corresponding to this wavelength? And you have been given Reidberg constant. So again, by applying the Reidberg formula, we are knowing that nu bar will be equals to R multiplied with 1 by n1 square minus 1 by n2 square. Here we have been given that electronic transition is from n is equals to 4 to n is equals to 2. So here n1 will be equals to 2 and n2 will be equals to 4. So by substituting the values of R, n1 and n2, we are getting the answer wave number as 20564.4 per centimeter. So after getting wave number, we are knowing that when we are for getting the wavelength, if we are going to do the reciprocal of it, then we are able to get the wavelength. So wavelength is equals to 1 upon nu bar, that will be equals to 1 divided by 20564.4 centimeter per centimeter. So after dividing it, we are getting 486 nanometers. So 486 nanometers, the color corresponding to blue color. It lies in visible region and it is of blue color. So I hope it's clear to you. Switching over to the next question. The question is, what is the maximum number of emission obtained when the excited electron of a hydrogen atom in n is equals to 6 drops to the ground state? Here we have to find out the maximum number of emission, means number of lines which are being emitted. So we can say that the number of lines produced with electrons from nth shell drops to ground state. Then we can calculate directly it by using the formula, that is summation over n2 minus n1. So after solving, we are knowing that n2 is 6 and n1 is 1. So we are getting summation over 5. So adding all upon, we are getting 15 lines directly from using the formula. And those transitions are, we can directly write the transition like, we are knowing that for dropping from n is equals to 6, n2 is equals to 6 to n2 is equals to n1 is equals to 1. So first is 6 to 5, 5 lines will be there, 6 to 5, 6 to 4, 6 to 3, like this. Again from 5, all are coming to 1, so 4 lines. Again from 4, all electronic transitions are coming to ground state, that is 3 lines. Now second one, again from third state to ground state, that is 3 to 2, 3 to 1, that is 2 line. And again from second energy level to first ground state, that is 1 line. So after adding 5, 4, 3, 2, 1, we are getting a total of 15 emission lines, 15 transitions will be there. So I hope this is clear to all of you students. So before concluding the today's lesson, we have discussed today about emission and absorption spectrum. So let me tell you one basic difference between both of them, as we are knowing that emission spectrum is obtained when the radiation from the source are directly analyzed in the spectroscope. So we can say that emission spectrum consists of bright color lines separated by dark spaces. It can be continuous spectrum or discontinuous. That is line spectrum. Discontinuous is line spectrum. If source emits some colored radiation. And on opposite to absorption spectrum, which is obtained when the white light is first passed through the substance and the transmitted light is analyzed in the spectroscope. So absorption spectrum consists of dark lines or otherwise continuous spectrum. So continuous, that is Vibgyor we are getting for absorption spectrum, and it is always discontinuous spectrum consisting of dark lines. So this is the basic difference between emission spectrum and absorption spectrum. I hope you have understood it. So today we have discussed about emission spectrum, absorption spectrum. We have also discussed about the atomic spectrum of hydrogen, including the series, different series and their regions. And we have also discussed about Reidberg formula for calculating the wave number or wavelength of the corresponding light. So, thank you students.